Okay, today we're going to talk about integration by parts, which is a very, very important technique for integration. So the formula is if u and v are functions of x and have continuous derivatives, then the integral of u dv is equal to uv minus the integral of v du. So the guidelines you want to use for this are to try to let dv be the most complicated portion of the integrand that fits a basic integration rule. Then u will be whatever's left over. Or you can try letting u be the portion of the integrand whose derivative is a function simpler than u. And then dv will be the remaining factors of the integrand. So what does all that mean? Well, here we have an example. We've got the integral of x e to the x dx. Okay, so what we're going to do is x is a real simple equation, so we're going to let u equal x. So we're going to let u equal x. And then we know that du, the derivative of x, is just dx. Okay, that means that dv is going to be the rest of it. So it's going to be e to the x dx. Okay, so here's u, and this is v. Or this is dv, sorry. And then v is going to be the integral of that, and the integral of e to the x dx is just e to the x. Okay, so now we've got all the parts that we need in our formula. We've got u, we've got v, and we've got du. So we can go right in and write our formula. So this is going to be equal to u times v, so x times e to the x, minus the integral of v, which is e to the x, du, which is dx. And now we've got to finish this part right here. This part's done. X e to the x minus, well, the integral of e to the x is just e to the x. And then we add plus c because it's an indefinite integral. And there we go. There's our solution.